So classes in object-oriented programming. So what is a class? Why do we need classes? So think of a class as a user-defined data type. Ints and floats can be useful in a lot of cases, but they can't cover anything. Sorry, cover everything. Objects in programming can represent real-world objects, such as people, animals, etc. We can make objects by first creating a class that represents a generic object of some type. Then we can create an instance of the class to represent a specific real-world object. The init function. The init function is basically a constructor, and you can just initialize the instance variables of the class using uh, the init function. So you have self, name, grade, GPA. You always want to put self here. That's the self. That's just referencing the class itself. So we have self.name equals name, self.grade equals grade, self.gpa equals GPA. And here outside of the class, we're creating two students called Ashwin and Alex with their details, and we will be able to access these details at a later time, either in the class or outside. If you're in the class, you want to do self dot if you can access attributes doing self.name. Outside you can do Ashwin.name or something like that. Uh, oh yeah, self keyword. So you always want to have the self keyword. It must be the first variable in its declaration. It refers to the instance of the class that is currently being used, and you can call it whatever you want, but the standard is to name itself. Accessing class attributes. So in order to access a specific attribute of an object, type object name, attribute name. So basically we have Ritvik, and then we're printing Ritvik.grade, and it prints 12 because we said 12 is the grade. So we have self.grade equals grade, and we're printing that, we get 12. Class functions. Whenever you call a method of an object created from a class, the object is automatically passed as the first argument using the self parameter. So, and then this enables you to modify the object's properties and execute tasks unique to that function, uh, or unique to that in particular instance. And then every function within a class should have self because you want to be able to access the attributes of the class within it. So here we have so we have the GPA of Ritwik 3.9, and we want to increase it. So we have function increase GPA with the parameter self only, and then we're returning self.gpa plus 0.1. So we're just returning the increased GPA, and that's 4.0. Uh, the string function. The string function is basically is in what's in the class, what the class is and where it's located if you don't specify exactly what it is. So string method returns a human readable string that represents your object and the data within it. You can define it or you can call it, and Python will return its default inbuilt implementation of the function. So if you want to know what's in this function, sorry, in an instance of of a class, without accessing each thing, you can just create a string function for that, sorry, string method for that, and you can put in whatever you want and return that. And here they want to return the first and last names of the class person, of an instance of the class person, and we're returning this. So that's the string function. If you don't put a string method of your own, you're gonna return the default implementation, which is some random memory location. This implementation is not particularly useful by any means. Um, so inheritance. So you have a class person. A class can inherit features from a parent class, making it a child class. So you have class person, and then student is the child class of that. And we are specifying that by putting person in parentheses during our declaration of the class. So student is going to be the child of person, which is the parent class. And parent and child don't necessarily mean like uh, the real world meanings. It's more of in a programming sense, the parent class and then the child class. The child is um the child of the parent class, not some human parent. So a child class inherits all methods and class variables from the parent. In order to access the parent's variables and methods, you must use the super.init function and the child's init function. By convention, the super function should be the first line of the child's init function. Inheritance is the mechanism to achieve the real. I'll come back to that. So here they basically have uh, the function normally. So they have the init function with all the details. And they also have the details not only for the student class, but also for the person class. And we're gonna get all that here. So they inited they inited not only this function, but also the super function. So we're doing super.init, the super class, not the function. So super.init for slash because that's what's in that. That's what the parent class needs. So for slash, and then for this particular class, class student, we're gonna do self.grade equals grade, self.gpa equals GPA. And here we're printing our name. And even though we created a student here, Ashwin, we're gonna use the print name method from the person class. So we're just printing Ashwin Kalyan. Oh, and then inheritance is the mechanism to achieve the reusability of code. So basically, it allows us to not create the same functions over and over again, and we can reuse the person class and the inherent attributes of a person for like a variety of things like student, banker, any other occupation. We can just use person and extend that. So here we have overriding. So overriding allows a child class to provide a specific implementation of a method that is already provided by one of its parent classes. As the name suggests, the child implementation of the method overrides the parent implementation when ran. So here we have the change name method, which is going to change the name of the person. So that's good. But if we go to the child class student, you can see here that it has a different change name method. This is called overriding. So we as the child class are going to say we don't like the parent class's method. We're gonna make our own of that. And this one, instead of doing all this, it's just gonna do self return self dot first plus string self dot grade. It doesn't want the last name being returned. So that is what overriding is, where the child class just overrides one of the parent class's methods because it feels as though it has a better um it has a better method to make in that regard.
Do you
So
want to like
mul-
give like a brief demonstration before we go into multiple inheritances? Basically, just like what we've learned so far. Yeah, just like a quick review
go
of like what we've covered so far, so we don't lose anything.
okay. Um see what we covered. So all the way to the first slide. Oh, okay, read it class. Let's just keep using student. That's a very um intuitive thing in it. Uh and then we have self, let's use name, GPA. Let's use school in this case, just to be different. And so what we're gonna do here is just we're gonna initialize all these variables, and we can do self.name equals name, so self.gpa equals GPA, self.school equals school, and when we come out of the class, we can make a new student. Oh, not like that though. We can make student one equals student uh oh equals, then we can say his GPA is like I don't know 3.9 something, and then we can say he goes to I don't know, John High School. So that's how you would do that. And then to access these attributes, one would just do this. Oh, and let's put that inside a print statement. Print student1 dot GPA. And that is 3.9. So we're just accessing the attribute inside the class. We can do that too. So we can just say, go back, def, let's say change GPA. And then let's say self new GPA because his GPA improved. So we're just gonna say self.gpa equals new GPA, and then we're gonna return the GPA new GPA just for the benefit of the runner class. So we're gonna say print student one. Uh, wait, let's do change GPA and student one dot change GPA, and let's just say he improved that to a 3.91, and we can see that it has indeed improved. So that's how you would make a function, and then we can make um let's say class math student because perhaps let's assume he's in college and he's doing a math major. So def init. So um and then let's say favorite math class. Let's just say favorite class. Um and then let's say super dot init, and let's put oh, and then we also have to copy these down. So and also I forgot to do student and copy that. So now we have to do name, GPA, and school again because the parent class needs that information to construct itself, and then we also need to construct this class itself. So self dot parent class equals parent class. So let's see what happens there. So let's just say math student. So favorite class. So let's say his favorite class is linear algebra. And then we can just print that out. So student one dot favorite class. And what is this? Not name, GPA, high school, favorite class. Wait.
Got the parentheses after super.
Out of what?
Parentheses after super.
Oh,
Yeah, yeah.
okay. So linear algebra. So you can see that you can just reference the slides because even I forgot that we need a parentheses. So just make sure to follow the correct syntax. So here we have student one of favorite class linear algebra. So that's good. Is there anything else? Oh, overloading. Uh, sorry, overriding. So change GPA. Let's put another change GPA function. Self new GPA. But here, let's just do self dot name equals new GPA for some reason. Uh, and then let's just return the your GPA anyway. So let's student one dot change GPA. Let's return I don't know. So we know that different. Um so student one dot change GPA 3. So it returns I don't know. So I think that's all we covered. Okay, moving on. If you have any questions, just type them uh in the chat. Change windows. Okay, I think Ashwin can explain multiple inheritances or Alex, depending
Okay.
on who's the best at it.
Okay. So in Python, unlike other programming languages, most notably like Java, was okay. Most notably like in languages like Java, multiple inheritances aren't allowed. Like you can't inherit more than one parent class. But Python is unique in that it actually allows that. So the general rule for multiple inheritance is that the subclass inherits all of the functions and attributes from every single parent class. So, like right here, dog gets all of the attributes from animal and all the attributes from mammal, and it gets roar and it gets have babies. Um, yeah. Plus, it gets its own attributed breed. So when you create a dog instance of the dog object, you have to specify its color, its name, its sound, whether it's warm blooded, whether it has babies, and what breed it is. All from animal, mammal, and the dog class itself. So you can see here that to inherit all of these attributes, you need to do animal dot init and then all the animal attributes and then mammal dot init and then all the mammal attributes. You have to do that for every single class that it inherits. And then plus you have to assign like the dog self dot breed equal to breed. So that is one way of doing achieving multiple inheritance in Python. If you go to the next slide, you can also use the super keyword that we talked about earlier. So so the thing you should note is that when you call super dot underscore init in dog like you would with normal inheritance, it first looks at mammal, like the mammal class, since that comes first in how I entered it in the program. And then if you don't explicitly call the animals constructor, the animal initialization would be skipped in this context. So that's why we have to do that separately if it's only super in it. Or you can do it like how it is in this picture where you call super in each parent class. And essentially what calling super in each of these parent classes does is that it like adds it to the it sets the MRO order. And we'll talk about MRO in a bit. And then you can call super all at once in the dog class. So just remember to have super dot init and then the arguments and animal, then mammal, and then you can call super dot init without any trouble in the dog class with all of the attributes from animal and mammal. So more about MRO is on the next slide. Actually, no, well, we'll talk about the diamond problem. So the reason a lot of programming languages don't allow multiple inheritances is because of a thing called the diamond problem. And here's a video about it that I made that explains it pretty well. So yeah, click on that.
Okay, hello everyone. Welcome to a sort of bonus episode of Code Catalyst Academy. We'll be talking about something called the diamond problem in Java. So essentially what the diamond problem is is, you know how in Java famously bans multiple inheritances. And the reason for this is the diamond problem. So, what is the diamond problem, and how is it so bad that you ban what seems like a useful feature as multiple inheritances? Well, to make things clear, let's say we have a class A. And class A has a function called print info. So with print info, class A can like print the attributes of the class. But then let's say class B comes into play, and class B extends from class A, but it provides its own implementation of print info, so it overrides class A's. And then let's say class C comes into play, and class C has as well like its own implementation of print info. So now we have class A's implementation and then class B overriding class A's and providing its own implementation, and class C overriding class A's and providing its own implementation. So in the child classes, we have two versions of print info. But then let's say a grandchild class comes into play and it inherits print info, but it extends from class B and class C. So now class D does not know which print info it should inherit. Should it do this one or should it do this one? Java can't pick for you, so the compiler just forfeits and crashes, and that causes a whole bunch of errors in your program. And especially in like large enterprise level projects where there can be a lot of multiple inheritances and like a lot of people coding, this can happen very often, and that will cause the entire program to crash, and it takes a lot of time to fix and sort through. So essentially what Java developers said was, we don't want to deal with this at all. Let's just circumvent the whole problem and ban multiple inheritances. So that's the diamond problem, and you can see here this whole structure here makes a big diamond, and that's where it gets its name. So that's the diamond problem. We hope this makes
Ashwin, do you want to cover this?
Okay. So that's why the diamond problem was banned. But Python decided that it didn't want to ban such a useful feature, so its developers instead developed MRO, which is a method of calculating which order of parent classes that it should inherit from birth, like which parent class it should look to first, and a first priority and then second priority, and then using that, it circumvents the diamond problem, which is pretty cool. So you can view the order, the MRO order, by using the underscore MRO function, or just using the regular MRO function. You don't need to know much about this, but it's just good to know in large projects that Python will take care of this for you. So on the next slide, we'll be doing sort of practice problem. So read the code, and what do you think this will return? You can either unmute or just type in the chat. Okay. I'll call on someone if no one wants to answer. Okay.
Let them read it. But
Okay.
I'm calling someone. Ashwin. Ashwin, do you want to call on someone?
okay, does anyone want to answer? Oh, go ahead. Ashwin, I can't hear if you're saying anything. Is it okay? Let's go on to the answers.
Um.
So,
Well, basically, but the other way around.
yeah, because you're gonna
Okay.
execute. You're gonna go inside the grandchild first. If you look here, and then you'll come back to the parent.
Yeah. So for this, so we have grandchild that inherits from the child class, which inherits from the parent class. Yeah. So the show function would be overriding, overriding the child's show function. So firstly, the grandchild will inherit show from the child. So it'll initially be printing inside child, but then it looks in its own class and realizes it actually has its own implementation. So it'll prefer its own implementation over the parents. So it'll print inside grandchild instead. And then the display class is from the grandparent class. Yeah. So child inherits the display from parent, and then grandchild inherits display from child. So it'll just say inside parent since no overriding was done. So yeah.
Okay, so Python does not support function overloading. It's basically having two functions with the same name but different parameters. This is supported in many other languages, but unfortunately, Python does not support this functionality.
Yeah, remember overloading is different than overriding. Because Python can override, and remember, like overriding is basically where you just have two methods that go by the same name but just different implementation. Whereas overloading, as specified in the slide, means they have different parameters.
Okay, so we can
Yeah,
do
it's a pretty important feature in Java. Also, Python doesn't support interfaces since interfaces as a feature was created to support multiple inheritances without actually doing multiple inheritances. So since Python has that, it doesn't need interfaces. And if you don't know what interfaces are, don't worry about it. So yeah. I think that's it for this. We we can switch to the air handling regex slideshow now, since we already did a practice problem.
Okay, errors, exceptions, and regex. Regex is basically regular expressions. They're quite useful in certain cases when you want to match patterns in your strings. So moving on, errors and exceptions. So the most common errors are syntax errors. These are um, glaringly obvious errors where you don't follow proper syntax, like you lack proper indentation, particularly in Python. You make spelling mistakes, those types of things, or syntax errors. Exceptions, also known as logical errors, are when a program is syntactically correct, but an error occurs when the program is executed. This is basically when you don't do proper logic and you maybe have like some sort of infinite loop or something like that, and that's a logical error. A logical exception. So built-in exceptions, you have index errors. So when the wrong index of a list is retrieved, if you go out of bounds. Assertion error, it occurs when the assert statement fails. Attribute error, it occurs when an attribute assignment is failed. Import error, if you import something that doesn't exist, get an import error. Key error, you don't have, if you're searching in a dictionary but you don't have that key, then that's an error. If you try to get a variable which doesn't exist, that's an error. If you don't have memory, that's also an error. Don't worry about memory error that much. It's not particularly relevant. Type error occurs when a function and operation are applied in an incorrect type. That's a type error. There are some examples: 10 times 1 over 0. 1 over 0 is inappropriate because you can't divide by 0 unless you're finding the limit of it or something. Traceback. Oh, we have name, var is not defined. So here that 4 plus 4 times 3. In nowhere did they say what var was, so that's wrong. Name error. You have obviously you can't concatenate strings with integers, so that's wrong. So that's a type error. That's not good. Exception handling. So we can handle exceptions using the try except method. This functionality exists in most languages, if not all. The try block is first executed to test for errors. If an error is encountered, the except block is executed. If no error is encountered, the else block is executed, and the finally block is executed no matter what happens there. So here we have we're taking some integer input, we're taking some input where we want an integer, and so uh, we're operating with the assumption that they're going to type in a number such as like 3 or -4, and so we're casting that to an int. However, this cast can fail if they enter something like hello, because that is not a number, and you cannot cast such things to an integer. So here we have except print that's not a valid number, try again. So in the case of the cast fails, we're going to accept that and print this. Otherwise, we're going to print no error. And regardless of whether there was an exception that occurred or whether there was no exception that occurred, we're going to do we're going to print done. So that's the finally block. You just print that regardless of what happens. This is just to say that we have finished executing this code. You can have multiple exceptions. Obviously, you can execute specific except blocks for specific errors. So for example, if you have if you're trying to print X but X doesn't exist, that's a name error, and we can predict that and say, oh, X doesn't exist, we're gonna accept name error and say variable X is not defined. We're gonna give ourselves a very specific message on what went wrong. And we're gonna go on and do except for general cases for all other types of errors and say something else went wrong. We don't know what it is. Oh, so we have regular expressions. They're a sequence of characters used to form a search pattern for a string or substring. To use it, first import the the re module in Python just by doing import re. Um, so functions, the re module has a couple of built-in functions. So the match function is going to return a match object. If so, match object is just what it returns in general. Um, it's a part of regex. Uh, so return a match object if there's a match at the beginning of the string. Otherwise, oh, and then we have find all returns a list containing all matches. This is particularly useful. Uh, search returns a match object if there's a match anywhere. Split, we're going to return a list where the string has been split at each match. This is also actually very useful. Sub replaces one or many matches with a string. Going to replace that match. Group returns the part of the string where there was a match. So yeah. Oh, we have regex meta characters. So here we can just say, so if you're trying to look for a specific sequence of letters, you can say, oh, we're looking at A through M, and put that in a bracket. Oh, and then we have the, what is this? It's the backslash. So we have the backslash. Signals a special sequence can also be used to escape special characters. So like this. Oh, dot is basically any character except new line character, so it's very useful in ignoring things. So, oh, and then the caret and the dollar sign are also gonna you're gonna use them a lot if you actually do regex because that's when you determine if something starts with something and also if it ends with something, and then zero, and then you have a variety of other things like star plus question mark if there's some sort of occurrences going on, or the curly brackets exactly the specified number of occurrences, and then either or, and then we have the what is this? The parentheses. Okay. So we have special sequences, backslash A, turns a match at the specified characters or at the beginning of the string, backslash B returns a match where the specified characters are at the beginning or at the end of the word, backslash big B returns a match where the specified characters are present but not at the beginning or at the end of the word. So you can look at this. Oh, I do want to mention slash backslash D. It returns a match where the string contains digits numbers from 0 to 9. This is very useful actually. And then special sequences. Uh, yeah, so you can just look at these on your own. There's like so many. Uh, so we have the R in the beginning is making sure that the string is being treated as a raw string. So you don't have to do double backslashes. So we have result equal re dot search, and then we're searching for the sequence, the world, and then it's printing result dot group, and the result is the D. So it matches the start of the string. Here we're matching any number, any single digit. So we get 2024. Result equal re dot search backslash w plus hello world. Hello world 123. So we're just gonna print hello world 123. It matches any word character. R dot search backslash b cat backslash b cat set on the mat, and we're just matching any position where word characters is adjacent. The dot group function is not actually particularly useful in this case. It doesn't, but whatever. That's the example, I guess. Okay. Do you have any questions about all that? Okay, I guess not then. So we can switch screens. Okay, class. So this is actually all useless, I guess, for purposes of this. And then let's look at what we can do. So let's do the input thing, because this is actually the main thing which you might actually do. That's x equals int input, please enter a num say an integer. And then accept, and then let's just say that's it. But I feel like there's only one exception that could occur here, so we're just gonna do print that is not an integer. And then we can just say finally print good. Oh, and then actually else don't have to do all you don't have to do all four. So let's just say print x. And then please enter an integer. So let's actually enter like hello. So that is not an integer, is instead. So that's an exception that we have. And then finally we're printing good. Because we're gonna print that regardless of what happens. Let's say we actually enter a good integer, so let's say 2, and then we're good. And we're actually good. And then um I suppose we could do RegEx. So we have import re, and then we can do result equals re dot search. Let's do one of the examples from let's do the digits example. So the first integer that it finds, so st plus, and then I don't know, to the I 5 fingers, and then well actually I have 10 fingers, but I have 5 fingers on one hand. I mean, maybe you can debate that if you don't think that thumb is a finger, but whatever. Print result dot group, and then print. So 5 is the first occurring digit in our expression in our string, and that is what we get. Oh, we can do a find all actually, and I think we can do the same one. So I have 5 fingers on one hand and 2 eyes. Uh, wait, go back. Uh, Someone else joined in now. Oh, so we don't actually have to do that. So let's go back. We don't have to do this. Let's just do result. So yeah, 5 and 2. So find all, match. So very good functions which you can use. I would say find all is one of the most useful ones of these, along with match, and group is also very good. Do you guys have any questions or something? The homework will be posted in announcements. You can do that. we don't have any questions, then we can end the call.
Yeah, and reminder, this is being recorded right now, so uh, if you need to refer back to anything, this will be posted at around like 6:30 Central Time. So just keep an eye out on the YouTube channel or the announcement channel in the Discord.
The recordings have been very helpful. Thank you. Oh, that's nice.
That'll end it. So
Okay, I think that's it.
yep.
Okay, we'll meet again for the final time tomorrow, I guess.